my name is Sahar. I'm a sophomore at UC Berkeley, and I'm here to tell you about your electrical system. But first, you should have completed assembling your mechanical kit. Now, we're going to start off with a board called Sherlock. This used to be the top board if you were a team last year. So Sherlock is also going to go on top of your microcontroller, the Panda. Now, you'll notice that the Sherlock pins and the Panda headers are in one position. You can't plug them in backwards. So you're going to put the pins inside the headers. You're going to firmly press down. Try not to bend the pins. Otherwise, it'll be very difficult to take it out and put it back in. So when you take it out, if you ever need to, make sure you don't bend your pins. Now, once Sherlock is on top of the Panda, you're going to take an XB. This is your radio. And you're going to put your XB in the XB slot. Before you do that, make sure you make note of your XB address on the back. Write it down somewhere because you're going to need it. So as you'll notice, there's a picture of the XB in the shape of the XB with an arrow pointing up. So this little top part of the XB also points up. Now you have another XB right here that goes into your USB breakout board. This also has some notches on the top to indicate the notches on your XB. So your two XBs are going to talk to each other when you're sending commands back and forth. Again, make sure to try not to bend your pins. And as you can see, this board has a USB port. It'll go into your computer. So you're going to have Sherlock right here. And you'll notice that there are no other, there's a few small connections, but you don't see everything like for your motors, your sensors, etc. like there was on last year's top board. That's because they've all been moved onto Watson. And Watson has these special connectors on here that are designed so everything can only go in one way. You can't plug them in backwards. Now the way Sherlock and Watson connect together is with what we call a ribbon cable or a parallel cable. So you can see there's all these lines in parallel. It's actually got 40 pins, and there's a notch on the front of each connector. And they go into these black headers right here where there's also a notch. Make sure the notches line up, otherwise you're plugging it in backwards and bad things could happen. So again, it should only go one way. Now, on Watson, this is where you're going to attach everything else to your kit. You've got everything labeled. So if you look here, it says D0 through D7. Those are for digital sensors and digital devices. A0 to A5 for analog. We've got something that says solenoid for your solenoid board. Flag is your team flag. Servo for your servo controllers. We've also got M0 through M5 for motors, M for motors, and then I2Z0 to I2C5. Those are for special sensors called I2C sensors. So this can go on your board anywhere. We've given you a nice long flexible cable. So I'm just going to set these down here for now. And the next thing that you have that is important is the team flag. This will be either blue or yellow, indicating what team you're on. And so what we're going to do is we're going to take one of these 3-pin wires here that have the same connector on both sides. And again, these only go in one way. So you're going to plug in one end into your flag, and now your other end is going to go to the flag spot on Watson. And what you also have, which are very important, are your motor controllers. These are called Grizzly Bear motor controllers. So what your Grizzly is going to do is it's going to get information from your code, and it's going to tell the motors which way to go. Now these also use a 3-pin wire. You'll notice that there's a 4-pin connector and a 3-pin connector. The 4-pin connector is used for encoders. The 3-pin connector is used to connect to Watson. So again, your wire should only go one way. And you should plug it into one of these ports that say M. Also, the way the motors are designed, it doesn't matter which M port you connect it to. because each one of these grizzlies has an address, and you set the address, and then whatever information you send to that address, it'll always go to the grizzly with the same address. And also, one very important thing is part of Sherlock is this big device over here called the battery buzzer. Now, the way these batteries are designed is they hold a lot of charge. They're very powerful, but they can't run too low. These are called lithium polymer batteries. If they run too low, they get dangerous. That is why at all times you need to have a buzzer plugged in. There's this place where people normally plug in buzzers. What we have done is soldered the buzzer directly onto Sherlock. If your battery gets too low, it's going to start beeping like crazy, and you have to take out your battery and charge it. And so the way we are enforcing that you use a buzzer is we have a special battery connector cable. There are two different connectors on the end. A special one that fits into the battery, like this. And then the other end will go into Sherlock. It's supposed to make that noise when you plug it in, but then once you do plug it in, it'll stop. This has to do with the way the buzzer is designed. So see, now it's done buzzing, and you see 3 green lights, so everything is good. So I've basically shown you how to connect everything control-wise, because there's 2 parts to your electrical system. There's what delivers the power, and there's what delivers the information, the control side. So I've shown you everything for delivering information. Again, keep note that if this is not connected here, your code will realize that your battery is not connected, and your robot will be disabled. So make sure that you connect your battery. So for the power system, what we're going to start with is this. It's a power distribution board. So what happens is that your battery is going to plug into here and distribute power everywhere else. The way you do that is your battery will plug into this wire here. We're not going to do it right now. But as you can see, there's a short red wire with a ring terminal, a long black wire with a ring terminal. And the way this works is you have this circuit breaker switch. It acts as an on and off switch, and also if there is something very wrong with your electronics and it gets very hot and currents run very high, which can be dangerous, this will shut it off. And so what you have here is on this part of the switch towards the top is a terminal labeled BAT. BAT is for battery. You're going to unscrew this nut here. And you're going to connect the red part of the ring terminal over here. Now you're going to screw this back on. Obviously I'm doing this by hand, but you guys should secure it tightly, get some sort of wrench or other tool to tighten this down. The other end of this goes to another short red wire you have with 2 ring terminals on either end. So for those of you who like electronics or want to be electrical engineers, you'll notice that this right here, the switch, is in series right now, because it's in between the battery and something else. And what it'll do is if you have the switch open, which means there's no connection, then you open the circuit and no current will flow. Again, this is all for safety reasons. So now the way this works right here is that you have your power distribution board, and there's 2 things right there. So what you're going to do is, I'm going to take this here, and the red ring should go here. And the black ring is going to go here. And this is how your battery is going to give power to everything. So now we're going to take some more wires and hook up a variety of devices to this. First thing we can do is plug in Sherlock, because otherwise you're not going to get power to anything. What you'll notice is there's these new yellow connectors we're using this year called XT60s. these are also designed to only be plugged in one way. If you want to plug in devices to your power distribution board, you'll notice that all of them on one end have a red connector, have a red wire with a bladed connector and a blue wire with a shielded connector. So the way it works is your blade will connect into this shielded area over here. And now you should notice red is connecting to this right here, so all the red devices hook up to one place. This shielded connector plugs into these blades right here. And again, you'll notice that the black wire is connected also to the black wire. And now, with your XT60, you'll see that these two connectors are also different. So this here is a female XT60 and this here is a male XT60. The way you can tell is that the male one has the prongs on the inside of this plastic jacket. So you're just going to plug this in like that, and now Sherlock has power. Now for your motor controller, it's also going to need power. And you'll notice that all of the power wires, again, this one is female, but as you'll notice on the motor controller, you have both a male and a female connector on here. So obviously this can only go in one place. This is so that you don't plug in power into the wrong spot and you don't plug in your motor into the other spot, because very bad things can happen if you switch those. This is why these are designed to only fit one way. So again, you're going to put the yellow XT60 connector in there. You can plug one end here, the black end, and you can plug the red end over here. Now, at this point, you might plug in your battery, turn it on, and then be like, wait, why isn't anything getting power? That's because this power distribution board also has another feature. You can put fuses inside. And what fuses do is, again, if the current is too high, it'll break the circuit and stop your electronics from breaking. So Sherlock doesn't take a lot of current. You only need a small fuse. So you have this small orange fuse with a 5 written on it. That stands for 5 amps. So the 5 amp fuse gets plugged in right here next to the red wire for Sherlock. Your motor controllers, on the other hand, take a lot of current because they're making your motor spin really fast. And so you actually need a 10 amp fuse. It'll say 10A on it, and these are gold and much bigger and bulkier than the other ones. This has to be plugged in right next to the red wire for your motor controller. So we're almost done here. The next thing we need to do is we need to plug this into a motor. As you can see here, we have some motors, and they both got shielded connectors on here. You're going to take the red and the black. Oh, this is the wrong wire. One way you can tell the wrong wire is that this shielded connector can't plug into a shielded connector. So, you know the right wire you're looking for here has a male XT60 on one end, which will fit into the Grizzly, and it's got 2 blades on the other end. Now you're going to plug your blades into the appropriate shielded wire over here. Now the thing about motors is it really doesn't necessarily matter which way you plug things in, except if you plug them in the wrong way, they're going to spin backwards from what you want it to spin. So that is why it is always a good idea to match up the colors and then set directions in your software instead. Because if someone plugs it in this way one day and someone plugs it in the other day the next and you don't change your software, everything's going to go backwards and you're going to be super confused. So now you're going to take the other end of the XT60, you're going to plug it into the Grizzly, and now you have one working motor. You can connect the other XT60, you can also connect this other XT60 up to another Grizzly, and again to the power distribution board, and you will have 2 motors running. One more thing that we're going to talk about is charging your battery. So when your buzzer goes off, your battery is low, you need to charge it. Also, you shouldn't wait till the buzzer to go off. If your battery is low, you can measure the voltage on it with a multimeter. You should definitely charge it earlier. In fact, if your buzzer goes off, that means it's at a dangerous level. So as you can see here, we have an XT60 connector. This will connect directly into your battery. On the other end is this AC adapter. And there is a round connection right over here. So you're going to plug this into here. And now from here you need to plug it into the wall. So you have a power cable, and as you can see here, these are also designed so that it's got a specific shape. You can't plug it in another way. You're going to plug it into here, and then plug the other end into your wall. That's how you charge your battery. When you're done charging your battery, you can unplug it, and you can plug it into your power distribution system, and your whole robot will start running once you load some code in and turn it on. So that was your electrical system. If you have any questions, please talk to your mentors or other members of Pi staff. Thank you.